Go. Okay, hello everyone. This is our presentation from group 7, and we'll talk about the critical path method in a project network. Our presentation is divided into four main parts. First is the introduction. We will talk about the general information of our project. This is the mathematical model, which is usually composed of relationships and variables. Besides, application is also important to make clear and problem we assign. Moreover, sensitivity analysis will help us to develop recommendations for the decision makers and feasibility of our optimal solution. Okay, now we step to the introduction. OR is a fundamental quantitative tool of management science which helps us to support the management apparatus to make the most reasonable decisions. Nowadays, application of OR has been used extensively, and methods to solve the OR project are simplex and lingo. There are 14 tasks for our project, and we name the mission of the task. First is learn about the stock market. Choose a company, find information and history of the chosen company. Get the company's annual report and do an analysis of indicators. Make a specific investment strategy. Evaluate the stock screening model. Open stock account. Ask for the staff or human resources at that company for information. Financial investment analysis and suppose the market share change in the future. Learn the trading discipline, risk management, collect the stock price data and make trades. Evaluate data and make group decisions whether to buy stocks. Okay, the activities that are critical to ensure that the project is finished in the minimum time. We use linear programming software, which is simplex, lingo, and critical path method, which stands for CBM, to solve the model. Okay, and the next is my presentation.
This section is about mathematical model. To solve this problem, first we need to draw a network to have an insight about the problem. Our group chose activity on the arrow network to illustrate the problem. Our solution, which is minimizing CMark and finding critical part, will be based on this network. Like you can see in the slide, the brown number is the processing time to go from to go to one node from the node before it. The black number is its predecessor. For instance, go from A to B takes 5 minutes to do job 1. Another example is go from F to H. We have to finish 2 jobs. Job 8 will take 6 minutes and job 9 will take 10 minutes. And our task is to find critical part, which is minimize the time to go from node A to node K of this process by formulate the mathematical model to solve. The following step is to determine set, index, decision variable, parameter, objective function, and constraints. I will tell you about first 3 parts. About the set, it's the number of jobs which name N here. And our index are I, J, K, where I is the precedent job, J is the immediate job, K is the original job. Our decision variable is each ij with the critical part. In this problem, each ij is binary, so each ij equal to 0 if the part is chosen, and equal to 1 if the part is chosen. And next, Dũng will tell you about other 3 parts.
3 spots that I present contain parameter, objective function, and constraint. In parameters, we have the processing time of job abbreviated as PHA, and the precedence relation between two jobs I and J abbreviated as EIJ. If EIJ is equal 1, there is a direct path from job I to job J. In the other way, EIJ equals 0, there is no direct path from job I to job J. The next part is about our objective function. As we know, the critical path is the longest path between the start and finish node of the project network. So the objective is maximum yes equal sigma from I to N, sigma from J to N, Xij products Pij. The next part is about our constraint. For each node, the total input flow must equal to total output to balance the flow equation. Our problem has only one beginning node and final node, so the critical path must go through both. Also, it's important to assure that each Hij follow the previous constraints. Our project has 5 constraints. It's about starting flow constraints with a sigma j equal 0 to n h1j equal 1. The next is ending flow constraints. It's about sigma is equal 1. It's about I from 0 to n s n equal 1. The next is balance flow constraints with a sigma from sigma I from 0 to n is I case equal sigma from j sigma j from 0 to n xkj which case is from its value case is from 1 to n minus 1. The next is the precedence constraints with a xij smaller equal or smaller than eij. The last is binary constraint with a xij equal 1 or equal 0. The next is about application.
So in this part, our group set out some application for our model. The first application is about the construction a house, which showed the diagram for the constructing a house. On tasks required to finish the house and estimated time for each have been identified. The arrow indicates the link between the various steps and their required sequence. As you can see, most of the job to be done can be stopped until the house foundation and frame are completed. It will take 5 days to finish the foundation and another 7 days to erect the house frame. The activities link the brown arrows from the critical part from this project. It tells us that the fastest possible time the house can be built is 38 days. The total time left for on the critical path task. The non-critical path job, those connected with the black arrows, can be delayed or bit done early. Short delays in installing application of roof won't delay the construction of the house because the activities don't rely on the critical part. So in the next application is about the production process. So the process layout arrange workflow around the production process. All workers performing the similar tasks are grouped together. Products brought from one workstation to another, but not necessarily to every workstation. On what we done in one area, so on examining in another and on inspection in another yet. The process layout with critical part is made from the procedure small numbers of a wide variety of products. typical using general purpose machine can be changed rapidly to new operation to different product design. For example, a manufacturer of custom machinery would be the process layout. So next is our team code about the model. So about the sensitivity analysis, our group have khoan tôi ta nói luôn phần này hả?
Bật mic lên. Bật mic lên Kiên.
Dân.
Tiếp tục.
Disruption, and I will continue with sensitivity analysis. Talk about the definition. Sensitivity analysis is a systematic study of how sensitive optimal solutions are changed in the data. In this problem, only can the change in coefficient occur, so our analysis mainly calculate the allowable range. As you can see from the table, we can see the current coefficient, allowable increase and allowable decrease. The variable is derived from that is satisfy the recent constraints. So as you can see, we can find the allowable range for each variable. For example, as the variable 0, 1, the current coefficient is 5, and the increase is 2, and the decrease is 5, which means the allowable range in here is from 5 minus 2 is equal to 3 to the 5. 5 decrease 5 is equal to 0 to the 5 plus 2 equal to 7. The next one is our programming. In this problem, we use simplex to calculate the completion time and the critical path. As you can see in the file, our project.mod is represent our mathematical model. And the next one is our data. Can you change the slide, please? The data in this data, our project.dit, the P and E is derived from the Excel, which means the system time and the residence constraint. And here is the recent matches, which is also known as the E parameter. And as you can see, from 0 to 1 is the way, which means it starts from 1, so there is always a way go to 1. And from the job 1 to the job 2, and job 1 and job 3, there is a way, so the is 1, 2, E1, 2, and E1, 3 is equal to 1. And the next one is the processing time matrix. In here, we take the data from our problem. As you can see, the processing time of job 1 is 5, job 2 is 6, and job 3 is 9, and so on. And the last one is our result. After run the model, we have the result that the completion time is equal to 55, and the critical path is equal to 1, 2, 4, 7, 10, 12, and 14. Also, we calculate the allowable range to Lingo by using this tool. So we have another code for Lingo. As you can see, it's similar to a simplex, and it's the results are the same. However, since since the analysis cannot work on the integral model, so we change the constraint from is binary to is larger than 0 and smaller than 1. That's the end of our presentation. Thank you for listening.